The key semiconductor is the advanced logic chip. It's the most expensive and complex piece of silicon that gives computers and smartphones their intelligence. Almost everything we use depends on silicon semiconductors, called chips. Today, about 1 trillion chips are made a year, or 128 for every person on the planet. And China's government is lending the industry the same strategic importance it gave to its atomic bomb program. Right now, there's one company that's crucial when it comes to making advanced logic chips: Taiwan Semiconductor Manufacturing Company, or TSMC. So when TSMC has a shortage, entire industries shut down, and this dependency on Taiwan worries Western countries.
The fact that China claims Taiwan, which is a democratically self-governing island, China has always said it wants to take over Taiwan by force if necessary.
But China's also worried, since they too rely on Taiwan, which has strong ties to the US for their chip imports. The result of all this? Multi-billion-dollar plans by multiple countries in a race to dominate the mother of all cutting-edge technologies. The transistors which give chips their functionality are small, very small. The smaller transistors are, the more you can fit into a chip, which in turn will offer more computing power. But making these chips has gotten so incredibly complicated and expensive that it's difficult to keep up. That's why the number of manufacturers at the industry's cutting edge has fallen from over 25 in 2000 to just 3.
The story of Intel's founding is also the story of how Silicon Valley got its name. William Shockley, the inventor of the transistor, the most basic building block of computing, moved to Mountain View to start Shockley Semiconductor Labs in 1956. A year later, the so-called traitorous 8 quit to start Fairchild Semiconductor, which quickly became the world's premier chip company. A decade later, 2 of these founding fathers of Silicon Valley, Bob Noyce and Gordon Moore, left to start their own company. They first called it NM Electronics, then quickly switched to the name Intel for Integrated Electronics. At Intel's founding in 1968, short-term memory, or RAM, didn't exist. Neither did microprocessors or CPUs, today's brains of every computer. Those are both Intel innovations.
These transistors are doing most advanced computational capabilities never thought possible, and it also enables the ecosystem all around us.
A short 3 years after raising an initial funding round of just $2.5 million, Intel went public with a market cap of $58 million. Making chips with memory capabilities was great business. So much so that well-established Japanese electronics companies like Hitachi and Fujitsu wanted in. A dozen years later, their massive factories, which had been operating 30-plus years longer than Intel's, were making memory chips far faster and more affordably than Intel could. In 1974, Intel's global market share of the memory business was nearly 83%, but by 1984, it was down to just 1.3%. So in 1985, Moore and then President Andy Grove famously fired themselves, walked out the door, then walked back in and made a drastic pivot away from memory chips and toward microprocessors. This was just 1 year after the first Mac computer came out.
They kind of made a decision, it's a huge one, to get out of that business and to bet the company effectively on this new market. Remember, there was no PC industry, there was no personal computer industry back then.
Last year, Intel announced it's selling most of what remains of its memory business to South Korean rival SK Hynix for $9 billion. In 1971, Intel released the 4004, the world's first central processing unit, or CPU. For the first time, engineers could purchase these building blocks to use in all kinds of electronic devices. Intel processors were in the world's first personal computer in 1974, and its groundbreaking x86 architecture processors were in the first IBM personal computers by 1981. It revolutionized transistor density and speed with the first 32-bit processor in 1985. It took competitor AMD 6 years to reverse engineer a similar product. Suddenly, personal computers had to have an Intel processor to be competitive. Andy Grove took over from Moore as CEO in 1987, and Time magazine named him Man of the Year in 1997. The market for personal computers continued to grow through the first decade of the 2000s, and Intel reigned supreme in making the chips that powered them. In 2011, global shipments of smartphones started sneaking past PCs. And that's about the same time Intel turned down an early offer from Apple to make crucial chips for its first iPhones.
And that was like a massive mistake, because what they actually missed, and that was the start of it, was the entire shift from PC to mobile.
The chip world was also in the midst of another trend. Back when Intel was first shipping out its revolutionary processors, chip companies took great pride in designing and making their own chips. Real men have fabs was a common saying at the time. But as Moore's law proved true decade after decade, chips got so complex that making them became an enormous undertaking. Building a fab today takes at least 2 years and $10 billion. So huge companies like Apple, Qualcomm, and Nvidia decided not to build fabs, but rather to outsource the expensive, highly specialized manufacturing process to companies like TSMC, which focuses only on its foundry business, making chips for others. Despite the wild success of companies that decided to focus on designing chips, like Apple, or only making chips, like TSMC, Intel still does it all. That makes it an integrated device manufacturer, or IDM. Keyvan Esfarjani joined Intel in 1996. Now he runs manufacturing and supply chain operations.
Advanced equipment capabilities are becoming more expensive. You got to get it right, otherwise it could be very, very costly.
Since Andy Grove retired in 1998, Intel has seen a series of chief executives who have gone back and forth about how much the company should focus on the costly manufacturing end of the chip business. The most recent turnover happened in February when Bob Swan was replaced by Pat Gelsinger, who started at Intel in the 70s at age 18.
30 years at the company. I mean, I joke, I went through puberty. I started at Intel so young.
At age 25, Gelsinger led the architecture of the 486 processor, then rose to Chief Technology Officer by 2001. He left in 2009, and after leading VMware as CEO for nearly 9 years, returned to run Intel this year.
We needed a technology leader to help reestablish the technology company, this company that essentially put the silicon in Silicon Valley.
Gelsinger's made some major moves since he took the helm, most notably the decision to double down on manufacturing. For decades, the markets have rewarded giants like Apple and Qualcomm for being fabless. But the chip shortage has made manufacturing chips a more attractive business, allowing TSMC, for example, to raise chip prices as much as 20%.
It takes time to build this infrastructure. But the good news is the world is rallying behind building additional capacity.
Intel is adding capacity by building a huge new fab at its massive campus outside Portland, Oregon.
D1X Mod 3 is about 250,000 square foot per level of the building.
We got an exclusive first look inside the expansion called D1X Mod 3.
And what exactly are you manufacturing?
We're manufacturing the latest generation of microprocessors for Intel and working to enable Intel's accelerated process for IDM 2.0.
At the company's Intel Accelerated event in July, Gelsinger laid out an aggressive IDM 2.0 roadmap for how it plans to ramp capacity and catch up with big leaps in processing technologies. By 2025, Intel says it will surpass the chip-making capabilities of both TSMC and Samsung.
We are on a march for yearly innovation, setting a pace for ourselves and the industry to not only get back, but to get ahead again.
Why should anyone trust Intel again? And so Intel will have to make a bunch of promises, both verbally and financially, in my opinion at least, to get anyone to listen.
Intel has 15 fabs all over the world: China, Israel, Ireland, and the US, in Oregon, Arizona, New Mexico, and Massachusetts. It has assembly and test sites in Vietnam, Malaysia, Costa Rica, and China and the US. It says it makes 8,000 products, outputting 2 billion units a year for some 2,000 customers. Now it's expanding that production specifically in the US and Europe. It's got a major fab expansion underway in Ireland and is reportedly in talks for projects in Italy and Germany.
Doubling down in its capacity requirement to support the growing needs of the customers around the world is absolutely a significant responsibility of what Intel's got to go drive.
And in March, Intel announced it's spending $20 billion to build 2 huge new fabs in Chandler, Arizona. It broke ground in September this year, with plans to output chips for PCs and data centers by 2024.
It's a very long time to build the concrete, the chemical delivery, the electrical systems. All of this needs to be perfect for a fab to run, for something that's creating lines and dimensions that are 10,000 times smaller than your hair.
When we toured the fab project in Oregon, semi-trucks were dropping off some of the 1,200 massive tools used to make the chips.
All of our tools tend to be in the millions of dollars, tens of millions of dollars. They weigh anywhere from 10,000 pounds to 100,000 pounds.
We also got a rare look inside the fab's bustling clean rooms, donning bunny suits that help keep dust and other particles away from the minuscule circuitry on the chips.
We're talking about clean room that is 10,000 times cleaner than a heart surgery room.
It's about the equivalent of about 20 American football fields is the amount of space we have here, which is clean room space.
It's filled with yellow light to prevent exposing the chips to shorter wavelengths of light than the lithography machines use to print designs on the chips.
We have different chemistries and gases that we use to make our chips here at Intel, and we segregate those exhaust streams into these ducts you see here and are subsequently treated so that we're environmentally responsible in providing clean air coming out of our factories.
Making chips also takes a massive amount of water, not a plentiful resource in the Arizona desert.
We're currently out at the Ronler Acres water treatment facility, where today we've reclaimed over 2 billion gallons of water and reused back into our manufacturing systems and process.
We utilize approximately 9 million gallons a day, and we conserve about 95% of that.
The chips being made here are 10 nanometer, used in PCs and data centers. Only TSMC and Samsung can currently make 5 nanometer chips, the most advanced node on the market. In fact, Intel relies on TSMC to make a good number of its chips.
We are one of their key customers, and that collaboration continues.
To understand why Intel has chips made by one of its competitors it's trying to catch, let's talk about the different types of chips and the supply chain. Different size chips are found in different types of electronics. Intel makes a lot of 10 and 14 nanometer server chips that function as the brains of computers, CPUs, and powerful chips used in data centers, GPUs. Less advanced 28 to 40 nanometer chips are used most in the auto industry, in components like anti-lock brakes and airbags. Bigger chips are also used in household devices like coffee makers or electric toothbrushes. 5 nanometer chips, the most advanced chips currently made, are highly sought after for data handling and artificial intelligence processing, used in leading-edge technologies like the latest iPhones, NASA rovers, and F-35 fighter jets. Making 5 nanometer chips requires an extreme ultraviolet lithography machine that uses very small rays of light to etch the tiniest designs onto the chips. Only one company, ASML, makes these EUV machines, and they cost upwards of $180 million.
Costs are going to go through the roof. But if you can't yield the process without it, like, you have no choice.
Intel didn't buy EUV machines until a couple years after TSMC, which explains why TSMC was able to reach 5 nanometer first. And now TSMC will be the first to make 5 nanometer chips in the US, building a $12 billion fab just down the road from Intel's new Arizona fabs. So where does all this leave Intel? It's currently in high volume production of 10 nanometer chips after years of delays.
10 was supposed to be here in 2015. We still don't even know the reasons. Their rationale for why 10 failed was that they just tried to do too much.
In July, Intel rebranded to avoid the nanometer-based nomenclature used by other chip giants. Its 7 nanometer chip, which it now calls Intel 4 or Meteor Lake, has been pushed back about a year. This recent delay, the first setback under Gelsinger, has 7 nanometer in production for the second half of 2022. Around the same time, both TSMC and Samsung have committed to start production on their 3 nanometer nodes.
They've been having process issues for 10 years. 14 nanometers was delayed, 10 nanometers was delayed, 7 nanometers was delayed. It's not like it's new. I still don't understand how you could let something slip as much as they have. Like, it's shocking.
We had some missteps. The strategy, had become a little bit confused on the role that we're going to play in manufacturing for the long term. And now we're leaning back into that with clarity, with clear urgency.
The competition between chip giants and subsequent ramp in production is a positive for the chip shortage, which has impacted all types of chips. Apple is cutting its 2021 production targets for the iPhone 13. Car makers like GM and Toyota have paused production at some plants. When the personal computer market skyrocketed during the pandemic, it drew down supplies of CPUs and GPUs. Intel blamed this component shortage for its PC chip business shrinking 2% in Q3 2021, causing shares to fall more than 10% after earnings were announced in October. Intel stands alone as the only US-based company that designs and manufactures advanced chips at scale. Traditionally, it only manufactures its own designs. But now, in the face of the shortage, it's changing that.
We are going to not only make our own wafers, we're also going to use those fabrication facilities to be producing wafers for customers that they want us to use their design. It's totally a right-hand turn. We have always had much debate about it.
Intel is calling the new standalone business Intel Foundry Services.
We've already have our first revenue with the Amazon packaging deal, our next big customers like Qualcomm and the US government.
Foundry has been wildly successful for the other two at the leading edge, Samsung and TSMC, but analysts are not sure it'll work for Intel.
Amazon presumably is going to be data center parts. Again, it's going to be that many units, right? Tiny, right? It's like 5 years away. And if it turns out that Intel is a viable foundry partner, great. But if they're not, it's no skin off their nose.
Really, the only benefit I would see to using Intel is if you wanted something to be created onshore in the United States.
And the government is greasing the rails with the CHIPS Act, a proposed $52 billion in subsidies for chip companies committed to making them in the U.S.
This is infrastructure.
In 1990, 37% of the world's semiconductors were made in the U.S., but last year that was down to just 12%.
A moonshot would be that the U.S. is at 30% of manufacturing in a decade or so in the future. And I think the CHIPS Act, as it's structured today, is a great step to start to turn that in a positive direction. As I like to joke, God decided where the oil reserves are, we can decide where the fabs are.
But analysts say much more is needed to help the U.S. bounce back. Because 92% of the world's 5-nanometer chips are currently made in Taiwan, the entire global chip supply is vulnerable to natural disasters common there, like earthquakes and its current drought, and escalating geopolitical tensions between China and Taiwan, and subsequently the U.S.-China trade war.
You need $15–20 billion to build just one semiconductor factory, and that factory is obsolete within 5 years. That means you need to be running that plant 24/7. It needs to be producing hundreds of millions of devices a year, and those devices need to be selling at a very high premium, otherwise you're losing money. And there are really only a few companies that understand the brutal, economics of the industry and that they can play that game and win.
But now the American champion Intel has shown signs of a slowdown. Although it's dominated the industry for the last 30 years, it's starting to fall behind in manufacturing and has announced that, like everyone else, it may start outsourcing some of its work to TSMC.
The birth and the growth of foundries. These are companies that specialize only in manufacturing and take designs from other companies and make them with the best process technology. In the past, they couldn't really keep up with Intel, but now, particularly TSMC and to a secondary extent Samsung, have actually got ahead. The net result of that is that a company like Qualcomm, a company like Apple, can design a processor, send that design around the world electronically, and have that design made into a piece of silicon on a more advanced process.
By volume, South Korea's Samsung actually makes more chips than any other manufacturer. But the company mainly focuses on memory chips rather than the custom-made logic chips that companies depend on TSMC for.
The economics and the technology, they've won. Above 30% of the most advanced logic is done in those factories in Hsinchu by TSMC engineers.
Both Samsung and Intel have recently announced multi-billion-dollar investments in the foundry business, although they won't be a threat to TSMC for years to come. But whether it's South Korea, the United States, or Taiwan, China's relationship with all three is less than ideal. Not to mention, a lot of the equipment and software provided to TSMC and Samsung to manufacture chips is made by US companies.
Applied Materials here in California, KLA Tencor, lots of these companies that you've never heard of are absolutely crucial in the supply chain in making these machines that then translate into these multi-billion-dollar factories that make chips.
And the US has leveraged its position to enact sanctions on China, banning the country from using US technology out of security concerns.
SMIC, China's top chip maker, signing an agreement to build a $2.5 billion semiconductor foundry or manufacturing plant with Shenzhen's government. And I think you'll see more of those private-public partnerships where a private giant or entity such as SMIC drives more efficient private capital into national objectives.
SMIC, or Semiconductor Manufacturing International Corporation, is China's largest foundry. Although it's still decades behind Taiwan's TSMC, China has shown its ability to throw money and human resources at the development of mega projects. But the chip industry isn't quite the same thing.
There have been numerous failures in terms of China's domestic chip development effort. SMIC is an example of a success, but there have been plenty more that have fallen by the wayside. Literally hundreds of much smaller corporations that you and I have never heard of that raised capital but ultimately failed to deliver on its goals.
TSMC has shown it takes much more than capital and human resources. It takes time.
It is just not very likely that you can create a comprehensive semiconductor ecosystem overnight.
And unlike the US or China, Taiwan's economy is largely built around semiconductors. TSMC is located in the small town of Hsinchu, which hosts a whole ecosystem of other well-established chip manufacturing and packaging companies. And the industry also attracts Taiwan's best talent.
A lot of school children would see the electrical engineering or anything that's related to the semiconductor manufacturing as their top choice when they decide on which university departments they want to go to. So in the US, you have students choosing to study computer science or other subjects that would be more related to the skills that big tech companies like Google or Amazon require.
Likewise, in China, students are much more likely to be attracted by companies like Tencent, Baidu, and Alibaba, or make their own app.
It's fine to build the world's best food delivery app, but at the same time, you need also to be able to attract talent into areas such as AI, quantum computing, basic scientific developments, what we call the hard sciences or hard tech.
To counter the lack of talent in the field, China's been recruiting talent from abroad, which has been controversial in Taiwan and the US, considering China's history of taking intellectual property.
And there is actually a well-known IP theft case. The US memory maker Micron has sued Taiwan's UMC and a number of engineers. Micron alleged that some of these engineers formerly had some know-how from Micron to help UMC's Chinese partner to build up their memory chips in China.
But all these resources and talent still don't necessarily equal success. To make a profit, companies like TSMC have a huge amount of orders from a diverse number of clients, and that also takes years to build up. So if Taiwan was suddenly cut off by a China invasion, for example, there is no TSMC replacement.
So without TSMC, you will not be able to have chips in your iPhones, and you will not have chips for your F-35 fighter jets that the US flies. So it will be a very different world we are talking about without TSMC in it.
This choke point came to light during the pandemic, when a chip shortage cost the auto industry billions of dollars.
Dial the clock back a year ago to early 2020, and the forecasts were dire. Economic activity around the world in the pandemic was going to come crashing down, and that was going to kill demand for semiconductors. What really happened, though, was as we were locked in our homes, studying and working from home, we felt an increasing need for the electronic services, for the electronic devices that had been around us all the time, but we felt a much more intense need for them. And that had a knock-on huge effect in creating demand for semiconductors. Roll the clock forward to where we are now, demand has come surging back. And it's come surging back in sectors where it really wasn't expected to. For example, the automotive industry, which thought that essentially the world was ending, that there was no demand for cars and they were going to have to shut plants down. They're having to shut plants down because they can't get enough chips.
This prompted the US to sign deals with TSMC and Samsung to build factories on their own turf.
If we see what's being billed as an electronic Cold War fully materialize, that China goes its own way in technology, that Europe and the US go in another direction, then perhaps it makes increasingly more economic sense to have facilities here.
The biggest economic choke point of the 20th century may have been oil passing through the Strait of Hormuz, but now it's microscopic silicon transistors manufactured in Taiwan. But while the US and China are fighting for control of the technology, they still depend on each other for the most part.
The trade war really is a case of be careful what you wish for. The chip industry brought attention to itself and lobbied for action against China for years on IP protection because they depend upon the Chinese market. It's the fastest growing, biggest market. They need to be able to sell chips into China. Right now, China needs them. China needs what they're producing.
Every aspect of defense, intelligence, and government operations is becoming more digital. And do we want to rely on foreign technology for those critical aspects of our defense and national security? I don't think so.
It's critically important for not just the global supply chain, but for the national security that we must maintain this journey. However, it is going to require Intel to put its playbook into work.
The next steps in this playbook include a chip so efficient, Intel's named it not with nanometers, but with an even smaller unit of measurement, the angstrom. Intel says the 18A, which is in development for 2025, will accelerate it past its competitors.
We will be the world's largest integrated design and manufacturer of silicon for the long term.
It is a tall order, and it is not my expectation that he will hit that. But if he could hit that timetable, it would put them back, in my opinion, on par with TSM head-to-head.
US and China and countries around the world lining up behind one or the other, it's not good for a lot of things. Just starting simply with global trade. But if I may be allowed to wax lyrical for a second.
Show that they need to be independent. The worst case scenario for the US is that China makes that leap, that this next 5-year plan or the 5-year plan after that finally hits home. Chinese chip manufacturers emerge and become competitive to Intel, to Nvidia, to Broadcom, to what Apple can produce inside.